Hello and welcome to this episode of Microchips. And on the bench today we have a couple of customer service radios, so I'll have a look at these. But before we start, don't forget to like, share, subscribe, comment, join Facebook, join Patreon, buy me a coffee, have a look at my website microchips.net where all my boards are. And let's get started. So to start off with, we have a Ham International Concorde 2, one of my favourite radios. So this one's not in too bad condition. It says here with a switch on the side. Okay, so switch on the side, switch on the back, a nice ventilation hole on the side. But all in all, not too bad. So, switch on the back looks like it's for the bleep, and we have a switch on the side that must be for 10 kc, which is a bit of a how you doing way of doing it. RF bias resistors not been done, audio limiters not been done, green VCO, PLL from 1981. So first off, we're going to do the RF bias resistors, because the bias on these is never right. So we just need to change a couple of resistors, so that one can come out and this one can come out as well. There's no adjustment for the pre-drive, but there is adjustment for the final. So we'll solder the two new resistors in place. We've got a 15 ohm and a 33 ohm that we've put in. So we'll get those in place and then we will check the voltage. Yep. So on the base of the final, SSB, no audio, and then we adjust the control for 0.7 of a volt. That's good enough. There's no control for the pre-drive. The pre-drive's always roughly right anyway, so we're not going to worry about that too much. Now, next thing we're going to do is we're going to fit a voltage feed VCO to this. These VCOs are always a bit tricky to remove because of all the metal case. As you can see, I'm struggling getting this one out, but finally it gives. So that can come out. And we're going to do the AVR capacitor as well. Always good to change it whilst we're in there. So here we have a voltage feed VCO. So this feeds the VCO directly with a stabilised 5 volt supply, which means a stable VCO voltage and hopefully some good audio on sideband. So we'll just need to go through the bands and just set the VCO. It's got quite a wide range on it, so there's no problem. Just go to the extremities of the channels and check them, no problem. Now let's have a look at the 692 and the 695. So from the test point, and we're going to adjust the two trimmers which are there. So we'll get onto the frequency counter and have a look at the, so 695 is not too far out, so we'll get that adjusted 695 just like so. Here we go, that's well within spec, and the 692 is an absolute mile out, so we'll get that into spec, and there we go, that'll do nicely. So that's our 2 carrier offsets done. Now let's have a look at carrier leakage. So SSB, no audio, and we just want to get these down, get these 2 controls down to as minimum as possible, which they are. So that's fine, no problem with that. Just trying all combinations of the controls to try and get it lower, but we seem to be as low as we can get. So that will do just nicely. Let's have a look at the final output frequency now. So 4 on 5, so it just needs bringing down just a little bit. And we're on 865, so that just needs to come up just a tiny little bit. There we go. It's as close as. And 965. There we go. Job's a good one. And of course, no repair video would be complete without the obligatory cyanide readings. So let's just have a look how the receiver's performing on this. And yeah, everything's to be expected. No problem at all. Not the most sensitive, but it's well within specification. Yeah, everything's just fine there. Quick listen in real world. Yep, everything's fine. Let's quickly go up to high band. Try that. Yeah. High seems to be a little bit more sensitive than the lower bands, so we can lower that out a little bit. So there you have it. That's a lot better, with a nice S9 on the meter. Now let's have a look at the audio FM discriminator. Make sure we're getting a nice sine wave. These are never usually too far out. And yeah, that's absolutely fine. No problem. So yeah, that's all good. Let's have a look at the SSB 2 tone whilst we're at it. Obviously if we overload it we're going to get some bit of flat topping, but apart from that the waveform just looks, yep, perfectly fine. Yep, just adjusting the 2-tone a little bit just to try and get a better trace on the scope. But yeah, tiny little bit of adjustment needed there, and yeah, we should be good. So what we'll do is we'll just adjust the SSB audio level just a tiny little bit, just to get rid of that little bit of a flat top.
Audio. audio, audio, 1, 2, 3, audio, audio.
Now we'll do the LSB offset.
Audio, audio, 1, 2, 3. Audio, 1, 2, 3, 3, 2, 1. Audio, audio.
Nice power output.
Audio.
And there's our Concorde 2, nicely serviced, and yeah, sounding good. That's to be expected for a Concorde. This can go back to its owner. And the next classic we have to look at is this HYGAIN 5. As you can see, this is the slightly better one with the clarifier and KC shift instead of the normal clarifier. These radios are supposed to be working, so we're just going to give it a once over, make sure all the necessary performance modifications are done. So let's see what this radio has to offer. So on initial inspection, everything looks as to be expected. Audio limiter needs changing, bias resistors need changing, VCO obviously, and 45th week of 1980 PLL. Well, somebody's already switched a bleep on this, as by that leg of the capacitor, which just cuts the delay. I'm not sure whether R166 is original, looks a little bit out of place. That does give a slight boost of audio. Now we'll look at the print side. I'm not sure what this is around the outputs, and the Darlington pair looks like it needs a bit of a solder, and we've got a wire link across something down there that shouldn't be there. Seems to be across one of the coils. But yeah, not sure what all that residue is around the outputs. So let's unsolder the Darlington. What we'll do is we'll clean it up, and we'll make sure that it's got a good solder connection, because these pads do like to break. So the pads look fine there. And whilst we're at it, we're going to give this a bit of a scrub with some 99% IPA and a toothbrush. Get rid of all that horrible residue that's there. So I have no idea what that is, but yeah, it's gone now anyway. And we'll clean up the Darlington area, have a good look at it. Oh yeah, doesn't look like there's any damage to any traces there, so a good solder up will sort that out. These cybernetics always seem to be covered in flux, probably from the wave soldering. So we'll pull the two resistors out for the bias, we'll pull the audio limiter, what we'll do is we'll just scratch a little bit extra back on these pads, just to give a little bit of extra for the solder to grab onto. And that should stop it from breaking loose in the future. Because you don't know how weak these pads are going to be. So if we just scratch a little bit back of the solder mask and then solder it up to that, it will make a good solid connection. So it doesn't have to be much, just a little bit like that, and then we'll give it a nice tinning and some soldering, just like so. Yep, very nice. Yep, good connection. That shouldn't be going dry. So we're on SSB, transmit, and again we're going to set for 0.7 of a volt on the final base. I'm going to wrestle another VCO block out, just like so. And we've fitted another voltage feed VCO. Just checking the VCO voltage on the extremities so that can come up a little bit. Yep, fantastic. I'll do this nicely for that. Quick check of the 10240. And we are within specification. We'll just get it as close as we can. Yeah, that's good enough. Now the carrier offsets, so 692 and 695. So 695 is not too far out. The control seems to be a little bit twitchy. Sometimes just giving it a good spin round sorts it back out again. So 10695 as close as, that'll do. 10692 is an absolute mile out. There we go. 692, that'll do nicely. Okay, that's good. Now we'll check the final output frequencies. So low band 26515 should be. Get it as close to. Yep. And 26965. We'll adjust that for as close as. Yep. There we go. And 415. Yep, fantastic. And now for the LSB offset. So we're going to listen against a known good radio and just adjust it for the best audio. So yeah, that's fine. Everything sounds nice. Even the bleep sounds nice. So that's working correctly. Now we'll do the AVR capacitor. Always best to change this. And some more of that crusty stuff that was around the outputs is round there as well. And now the obligatory cyanide readings, because you know no repair would be complete without these all important cyanide readings. So just checking it against some known figures. Minus 72 will be an S9 on the meter, and anywhere from 110 to 120 is always a good figure for the cyanide reading. There. Oh yeah, it's fine. I'll just listen to it in real life. So yeah, all sounding good. And the last one, we're going to do the FM discriminator. Just check we've got a good sine wave, which we have. Not much adjustment needed there, so yeah. And there we have it, another HYGAIN 5. Another HYGAIN 5 done. And yeah, always a nice radio, these. Anyway, don't forget to like, share, subscribe, comment, join Facebook, Patreon, buy me a coffee, have a look at my website, microchips.net, where all my boards are. Thanks for watching, and we'll see you in the next episode.